The fancy word for counting is combinatorics. And this is permutations, combinations is a branch of mathematics called combinatorics, and it's about counting things. So we have already learned about the fundamental counting principle. Here's an example. A new car is being built. You have choice of 3 different colors, 2 different transmissions, and 2 interiors. How many choices do they have? Well, this is a fundamental counting question. You have 3 decisions. Your first decision is color, your second decision is transmission, and your third decision is what is the interior going to be. How many choices for color do you have? 3. Choices for transmissions, 2 and 2, and you multiply them together. And there would be 12 different ways that your car could be built. Now you probably have way more choices than that if you actually go to a dealership, because most cars come in more than just 3 colors. Now, one of the things that comes up with the fundamental counting principle, especially with questions involving numbers, is what's the difference when you're allowed to use numbers more than once, and what's the difference when you're not allowed to use numbers more than once. So if I was allowed to use the numbers only 1 through 7, and I wasn't allowed to repeat the numbers, well, I'd have 3 decisions to make. How many choices for the first number? 7, because I'm using the numbers 1 through 7. Then one of the numbers is used up. If I'm not allowed to repeat, now how many choices are there? 6, and then 5. If you were allowed repetition, oh, by the way, this is 210. If you were allowed repetition, there'd be 7 choices here, 7 choices here, 7 choices there. And multiplying those together is you. 343. How many 3-digit numbers, and again, for this one, what we're going to use the numbers 1 through 7 again. And here is something that's new that we haven't dealt with very much before. This is a restriction. How many 3-digit numbers are even, and if you're not allowed to repeat? So you still have 3 decisions to make, okay? And how many choices do you have for your first one? If we started with the first one, you'd say 7, and this is not the right strategy, so don't write this down. Because I've got the strategy right here, deal with the restriction first. But if you said, I have 7 choices for my first one, 6 for my second one, my last one has to be even. How many choices do I have? 3. Well, what happens if I chose my 4 already? Right? If I chose my 4, then I don't have 3 choices for my even. Then I have 2. But what happens if I didn't choose the 4? If I chose the 5 and the 1, then it would be 3. So I have a problem that if I don't start with my restriction, I don't know how many numbers I can put in there. But if I started with the restriction and said, okay, I'm going to put one of my 3 even numbers here. Now how many choices do I have for my first number? 6. And then 5. 90 in total. Again, for part B, or the next one, we're going to use the numbers 1 to 7. And I want you to figure this one out in 2 different ways. How many used the strategy where they went 3 spaces? They said this one has to be odd, giving 4 choices. How many choices left for the first digit? 6, and then 5. And you got 120. Did someone come up with another strategy? Okay. So this strategy that I'm going to show you next, I give it a name. I call it the not strategy. And the not strategy says if you know what all of them are, and you can count the ones that are not what you're trying to count, or the bad ones, if you take all and subtract the bad ones, you'd be left with the good ones. So can you see in example 2, we counted them all. How many were there in total? 210. Okay? Which ones are the bad ones? If we're trying to count even ones, which ones are bad? I mean, if we're trying to count odd ones, which ones are bad? Even. How many even ones were there from example 3? There was 90. Right? Example 3, we counted how many were even. We got 90 of them. And so if you took 120, which was all of them, subtracted the even ones, you also get 120. So we're going to find out sometimes we're going to need to use this NOT strategy, especially it's going to be easier when it's easier to count bad ones. Then you're going to use the NOT strategy and say, I can count them all, I can count the bad ones, and what I'm left with is all the good ones. All right, we'll do this one this afternoon.